Hey, so today we are taking and looking at section 11.4 from your book, and it is linear transformations from the parent function. Okay, so first things first, when I say the word transformation, what comes to mind? Transformers. That's 100% where I was going to it. Every time I do this, the first thing I think of is Optimus Prime and Transformers. 100%. Bumblebee. Haven't seen the actual individual Bumblebee movie, but y'all get what I'm talking about. All right? Yeah, so here's what it is. Basically, when you think of a transformer, you've got a monster machine that is transforming between a car and that, going back and forth, yada, yada, yada. Okay? When we say transformations in math class, we are literally thinking, hey, here is kind of your parent function. Here's the one thing that you're used to. And then how does it change? How does it shift? What makes it what? All right? That's kind of where we're going. So the parent function that we are looking at, you can see up here is on your notes, is y is equal to x. Okay? That is the overall general parent function. Now, I'm going to draw a little sketch right here so you can have an idea of what y equals x means. Here's the graph of y equals x, and I'm no artist, but this is one of my better drawings. Yeah, it's not, but I appreciate y'all saying that it was, okay? So, it is this line that just goes through it, and it basically, it's over one, up one, over one, up one, over one, up one, all the way down. Or you could go down one left, down one, down left, down one, down left, down one, or left one, down one. Y'all know what I mean, all right? That's the parent function that you're looking at. Now, what we're going to do is talk about when you add things to it, how it changes it, okay? And the idea that you can see down here is we are really going to think about it from an idea of y is equal to mx plus b. Because a linear function really is just that original parent function moved around. Okay? Now, a lot of times we solve for it and then we plot a point and we just count to figure out what it is. But you could take that line and shift it right or left, shift it up or down, tilt it one way or another, depending on several factors, okay? Now, those factors are up here in these boxes, okay? So, I want to start with them one at a time, all right? The first one we are going to look at, okay, is this one that I am highlighting in red, okay? It deals with the sign that is out in front. Okay? And here's what this box says. The sign of the slope indicates whether the line has been reflected across the x-axis. If it is positive, it is not reflected. If it is negative, it has been reflected. Okay? So that's all about reflections. We'll see that in a second, what I'm talking about. All right? But here's the big thing you need to know is if you see a negative on your slope, then you would say it is reflected. Okay? That's the big takeaway. That's the big key. Now, to tie into that, the next thing we're going to look at is what your slope actually does. Okay? So, that would be this green box, the box that is all the way at the top. Okay? So, I'm making it green. Here is what a slope does, and I know y'all can read, but I'm going to read the sentence and then paraphrase it for you. It says, the absolute value of the slope of the equation indicates whether the line has a vertical stretch or a vertical shrink. Now, when I say absolute value, what do you think? When I say absolute value, has anybody ever heard of that before? No, but yeah. You're like, that sounds kind of familiar. Here's what absolute value means. Ignore the sign, just look at the value of it. Okay? So it's kind of like directions. All right, if anybody ever talks to you about directions, or if you ever looked at a direction on a coordinate plane, to some people, if you said to go west, they would say that, oh, that means I'm going negative direction that way. Because west is to the left, they think of a coordinate plane, oh, I'm going in the negative direction. So if they said go 5 units, you would go negative 5 units. But if you think about how you traveled, did you really lose 5 steps? No, you just went 5 steps to the left. That's what absolute value does, is it makes you think of the actual distance you go. So it's not like, hey, I walked to the refrigerator and then I walked back. You wouldn't say, oh, I went 0 steps because I'm in the same spot. You would say, well, I walked 5 steps, then I took 5 steps this way. So even though I started in the same spot, it was 10 total steps. Okay? That's kind of what absolute value is. All right, now, here are the things you need to take away when you're looking at the slope. If the slope is greater than 1, so what does that mean? This means, I don't want the highlighter. This means, I'm going to zoom in on this. This means bigger than 1. Okay? If it is bigger than 1, it is a vertical stretch. When you think of stretch, what do you think? Yeah. Vertical stretch is it's going to get almost like if you think of a rubber band and you vertically stretch it, it's going to get taller and skinnier. So here, look, you can literally think of it like this. Instead of being like this, if it's a vertical stretch, it's going to get more upright. So it's going to go more up and down. If your slope is less than 1, then that is a vertical shrink. So it's going to get kind of flatter. All right. So when you think vertical shrink, you should think less than 1. Okay. Now, it's not there, but I just want to mention it. If your slope is 1, that just means there is no change. Okay. All right. Then the last box that we're going to look at is your y-intercept and what your y-intercept does. I am coloring this blue. Okay. Your y-intercept does this. It tells you whether you shift your line up or down. Okay? So all it is an up or down shift. Y'all with me? It's going up. What do you think it means if it's going up? It is positive. If it's going down, it is negative. All right, now, so I'm just going to show you again. I'm just going to highlight each part and what it kind of tells you. So you see how each of these go with their assigned thing. So the y and the x don't tell you anything. It's all the other parts. So if I gave you the equation that is right there in the gray circle, everybody with it? Here is what a question would look like. It would say, hey, tell me the following transformations from the parent function y equals x. So you would be given this nice, pretty equation. And you would have to tell me what each of those things means and what it does. So looking at it, the first thing, it says it is reflected across the x-axis. The reason you know that is because the slope is negative. If the slope was positive, that would not be here. The only reason it is here is because your slope is negative. Because when the slope is negative, it means your graph is reflected across the x-axis. Okay? Now, the next thing, it says it has a vertical shrink by a factor of 1/2. How it gets that? You look at your slope. Okay? You ignore the sign. Well, the slope is 1/2. Is that bigger than 1 or is that less than 1? It is less than 1. So since it is less than 1, that means it's a vertical shrink. You always list your factor so that whoever is looking at your work or grading your work knows what you were thinking and what you were talking about. Okay? Okay? All right. Now, the last thing is it says it shifts up 4 units. Well, that comes from your y-intercept because it was plus 4. So that means you take whatever that original equation was and just shift it up 4 units. Are y'all with me? Are you sure?
Not really.
Okay. Where'd I lose you?
The start.
The start. Okay. Do you think that we could kind of look at an example and make that better? Or do you want me to go through what this exact example is saying?
An example.
Okay, so let's try an example. If not, we'll come back here and we'll go through that. All right, so if you flip over to the back, okay, the directions are the same for all of these. They ask you to list the transformations that occur from the parent function y is equal to x. All right, so the first thing that I'm going to do is I'm going to list slope-intercept form. Y is equal to mx plus b, just because that helps me out. All right, so as I look at this first example right here, all right, it was y equals x. Now, it's y is equal to 3/2. The first thing I need to check, is my slope positive or negative? My slope is positive. So I'm just going to make a note. You don't always have to write this, but I'm going to say slope is positive. Okay? Since the slope is positive, will there be a reflection? No. The only time you get a reflection is when your slope is negative. Okay, so I'm just going to make a note to me. That means no reflection. Okay? You don't always have to do this, but I'm walking you through kind of what my brain process is for this. All right, now, the next thing I'm going to look at. What number is my slope?
3/2.
Slope is 3/2. So the next question, is that bigger than 1 or is that less than 1?
Bigger than 1.
It is bigger than 1. Okay? Bigger than 1. So that means I have a vertical stretch. Because whenever your slope is bigger than 1, it is a vertical stretch because you're stretching it versus a vertical shrink. Okay? Then the last thing I need to look at is my y-intercept. Well, my y-intercept is -1. Okay? Your y-intercept simply looks at shifts up and shifts down. Well, since it's -1, I would say it does what? Down 1 unit. Okay? So, I've listed all that, but here's all you would really have to write. Okay? That's what goes through my mind. Here is the information that needs to be written down. Y'all with me? Okay? Looking at this, I would just have to look at this and say, okay, it's got a vertical stretch by 3/2 by 3/2. But again, the reason I knew it was a vertical stretch is it's bigger than 1. And then I would also have to write that it shifts down 1 unit. Okay? The reason I know it shifts down 1 unit is because my B value is negative. That is all that I have to write to answer this question. The rest of what I wrote is simply there to let you know how my brain goes through these kind of problems. Are y'all with me? Okay. Do you want to see one more together? Yes. Okay. Let's keep going. Let's look at the one directly next to it. Okay. Again, here is y is equal to what? X plus 3. So, my thought, is the slope positive or negative? Positive. So will I have a reflection? No. So I'm going to say no reflection. Okay? You don't have to write this, but that's what I'm thinking. All right, so no reflection. I'm good. Next thing I'm thinking, what is my slope?
1.
M equals 1. Well, is that bigger than 1? Is that less than 1? Or is that equal to 1? Okay? When it's equal to 1, that means there is no change. Okay? Or I guess better, instead of saying change, I'm going to say there is no stretch or shrink. Okay? Is that hard to see? Okay. There's no stretch or shrink. That's the big thing there. M is 1, there's no stretch or shrink. And then the last thing, your slope is positive, or excuse me, your y-intercept is positive 3. Well, that means we're going to shift which direction? No. Okay. It's the y-intercept. Where does the y-axis on the graph? It goes up and down. So you're either shifting up or you're shifting down. You are absolutely correct. You will shift up how many units? 3. Okay, now, I've written all that stuff down. Again, as you get comfortable with this, you don't have to write all that down because none of this actually answers the question. All they ask us for is what changes. Well, there's no reflection. I don't have to say that because nothing happened. There's no stretch or shrink. I don't have to say that because nothing happened. The only thing that happened was a shift up 3 units. So I would literally just say, hey, this shifts up 3 units.
That'll be an answer.
And that's your answer.
Can you do one more?
I will absolutely do one more. Here's what I'm going to do, though. I want y'all to start it, and then I'll finish it once we come back from lunch. All right, so after our nice, quick 20-minute lunch break, here we are again. So, all right, so some of you came up and showed me right here. All right, now, this is the one, y is equal to negative 4x. All right, so the things that I notice here is 1, there is a negative. So that does mean there is a reflection. Okay? So that's one thing that's going to happen. Now, somebody was arguing with me. Oh, it's negative 4. It's a stretch of negative 4. We talked about it. Okay? It is not the negative part. It is a stretch. When you see that your slope is 4, that does mean vertical stretch. Okay? Because it is bigger than 1. The negative means nothing. Now, in this next one, the part that has nothing is there's no vertical shift because there's no plus or minus at the end. So the things that you would need to write is say there is a reflection across the x-axis. All right, and then you've got a vertical stretch right there. So you need to write down a vertical stretch, okay, by 4. All right, now, the question that was asked was, do you have to write all that stuff down? Yes. All right, so let's look at our next example. So we're going to go down here to the bottom left, all right? Now, let's check this out. We're struggling a little bit, so I want to make sure we understand each of this. And this time, we're just going to write down our answers as they come to us, okay? So we don't have to go back and rewrite it. As I look at this, the first thing I look, is there a negative in front of my slope?
Yes.
Yes. That tells me right now that I have a reflection across the x-axis. All right, so by doing that, check. I know what the negative is saying. The next thing I need to look at is the number that is my slope. What is it? No, I don't care about the negative. It is the number 3/4. Is that number bigger than 1 or less than 1? It is less than 1. Since it is less than 1, that means we will have a vertical shrink. Okay? How I try to think about it, what makes sense to me is 1 is kind of the plateau. If it's smaller than 1, I think of something that is small, you have to shrink it. Okay? If something is bigger than 1, well, to make something bigger, I would have to stretch it. I personally think of a rubber band. If I've got a rubber band and I want to shrink the rubber band, I've got to push it down. I got to make it smaller. If I want to stretch the rubber band, I pull it to make it bigger. That's what I think of. Okay? Now, it is a vertical shrink. I want you to tell me what it is by. Well, what is the number?
3/4.
So it's a vertical shrink by
3/4.
3/4. Okay? All right. Then, the last thing here, looking at this. All right? Okay? Looking at this. You have to then look at your slope intercept. Okay? Not your slope intercept, your y-intercept. What number is back here? -2. Okay? Well, it's your y-intercept, so it's going to go up or down just like the y-axis. Well, -2 goes which direction? Down. So you would then just say it goes shift down 2 units. So at that point, you're done. What I have done, maybe me writing down what I was thinking confused y'all. But you can literally just look at it most of the time and go. All right, now, these last two examples. All right, we're safe. All right, now, these last two examples are ones that are a little bit different. Okay? So, look at this next one in the middle. What is different about it than anything else?
There's 2 variables.
Yeah, well, that's not really different. Haven't there been 2 variables on all of them?
Never mind, yeah, never mind. It's on the same side.
It is, yes, they're on the same side. It is not in slope-intercept form. So guess what we've got to do before we talk about it? We've got to put it in slope-intercept form. So, first thing I'm going to do is subtract my 3x. So you get -2y equals -3x plus 6. Then, to get y by itself, you've got to divide everything by -2. Remember, we're dividing everything because there's a plus sign on the right-hand side. That leaves you with y is equal to 2 negatives make positive 3/2x, and then 6 divided by -2 is -3. Now, at this point, this is what you have to use to talk about the transformation. So, I look at this. And the first thing I see, is there a negative out in front? So that means there's no reflection. I don't have to talk about it. Y'all with me? Like it's not there, forget about it. It's done. All right. Now, the next thing here. So the negative's not there, it doesn't matter. What is my slope? 3/2.
Bigger than 1.
That is bigger than 1. That is 100% correct. So therefore, I know I'm going to have a vertical stretch. Stretch is bigger than 1, and it is a vertical stretch by 3/2. Okay? Now, the last thing then is to look at your y-intercept. -3. Well, it's a y-intercept, so it's got to go up or down. Well, it's negative, so it goes down. Y'all got it. So it is a shift down 3 units. That is your final answer. All right, one more example. Do y'all want me to just go ahead and do it? We're just going to go ahead and do it. We're just going to go ahead and do it. We're going ahead and doing it. All right, so is it in slope-intercept form? No. Got to make it. So I subtract my x. Perfect. Y equals -x plus 1. Now we go through and list what we see. Is there a negative sign?
Yes.
So that means there is a reflection across the x-axis. Okay? Number 2, what is our slope?
1.
1, because there's a negative there, but there's no number, so it's the number 1. Does 1 change anything about a stretch or a shrink? No. So we ignore it. We go to the last one. It's a positive 1. So that is what?
Shifts 1 unit up.
Yep, so it shifts 1 unit up. Now, I'm going to tell you this because this is what students struggle with. When they look at this, they will typically say it's a vertical stretch by 1 unit because they think, oh, something's always got to be there. It doesn't. If the slope is 1, it's just nothing. Whatever is added on after it is what goes up or down. Okay? All right, so now I'm going to pass out to you your homework, and I'll let you do that.